Hey guys, just going to do a little video on how to set up tools and a program on a Mazatrol Cam T2 controller. So, here's our tool data page, which you get to through the menus and then tool data. It's got each tool you've got and a file number. So the different file numbers, if you go down to the tool file, that lists all of the tools that you've got in your collection, I guess, and all their different details that the controller needs. So the tools I'll be using for this job is that little fella there for my external turning, a center drill, 12mm drill, and a groove turn tool. So what we've got there in our tool data, we've got number 2, which is my external tool. If you look in the tool file, so it's a general out style tool. Holder 1, which means it's an external style holder, so a square shank holder versus a round shank. The angle there, the cutting angle, so that's this face here, and then that angle there, 55, is the included angle of the point, so around there, and it needs all of this info so it can work out what kind of angle it can put on a back face of something. Width 20, so that's just the width of the shank. So back in the tool data page, you tell it which file number it is, so it's number 2, and then that fills out that being a general out. Then you have to give it a nose radius, which is 0.8 on this insert, and then a rotation, spindle rotation, which is just forward because it's a regular, and it's a right hand holder, and you can put spare tools and a lifetime and number of uses in there if you like. So say I had 2 of the same tool in tools number 1 and 2, I could set number 2 as the spare tool, so then after it's done 100 cuts, if I put 100 in there, it'll start using number 2 instead of number 1. And then, so after you've set the tool up in there, told it what the tool is, then you need to go into tool set. Now I've already got this one measured in because I use it all the time, but to measure it anyway, you bring it around, so using the tool select button, bring it around to the right spot, hit tool set measure, this will bring down your tool eye, and then you just manually jog it up into position. Nice and close, and then come over, tell it which way you're going to be measuring from, and then it'll put it into jog mode automatically. So I always like to jog away for a second just in case, so I don't smash through my tool setter, and then you jog in until it beeps. And then we can go back into manual again, move it up to measure the point. Then we want to change it to down because we're measuring it from the top now. Hit jog, so it's in jog mode. Jog away and then towards until it beeps. Back off again. And there we are, that's setting up a tool. For other tools, there's some slight differences in the tool file. Focus. So if you're talking about like a drill, so for a drill, it's a number 2 holder because it's an internal holder. So you have just your point angle, your tip angle, being 118, and then just the width of the drill bit. This really only comes into play when you're doing when you're running a simulation. because if you tell it it's a 6mm in there and you're trying to drill a 12mm hole, the simulation will show a 6mm hole. That's really all that does. And then if we're talking grooving tools, so grooving tools, you have, so the first one, which is actually your depth, so 12mm being the deepest that grooving tool can go, and that's your width on the second one, so 2mm wide grooving tool that goes down to 12mm deep. So now I'm going to go through writing a new program on the Cam T2. So what you want to do is first go into the program screen, hit work number. I'm just going to do number 1 because this is just a single thing that I'm making. Doesn't matter, choose whichever number you want. Then it'll ask you if you want a new program. Hit program to make a new program. So first thing is material. So I'm using aluminium here. OD max, which is the max of whatever your material is. So I think I'm about 31 there. Call that 31. ID, so this is if you're starting with hollow bar. I'm not, so the ID is 0. Length is only really important, like it doesn't matter if you put longer than what your part is. I generally put it there to remind myself what length I need to cut stock off for the job that I'm doing. But yeah, as long as it's over what you're going to be machining, then it's fine. It's more of a simulation thing again. So I'll just put 100 in there, it doesn't really matter. So RPM, so this is your max limit. I'm quite happy to spin this as quite stable. I'll spin it right up to 4,000, so that's fine. Finish in X, so this is your finish allowance, so what depth of cut it will take for its finishing cut, and this is a radial measurement, not a diametric. So I'll just go 0.4 on that, and then your finish in Z, 0.2, and work face, so this is how much stock is hanging out further than where your Z0 is going to be. So I'll just say 1 because I'll just face off a little bit. So then you start getting into the actual programming part of things. I always just put cooling on at the start. I'll just go M code, cooling on, happy days, down to go to the next bit. And then I'll do an edge, which is to face it off. So this is where your cutting speeds and feeds, etc. go. They can be just calculated automatically from your parameters that you've got in there. So if you just hit the auto button, fills that stuff in. Obviously the machine actually can't get to those speeds, but close enough. So your depth there is the depth of cut, and that's a radial measurement again. So you might want to put that up or down depending on what you're doing. Gear ratio doesn't really apply. Don't need to change gears, don't have one gear. So there you've got your roughing tool and your finishing tool, if that ever decides to focus. So I'll be using tool number 1 for all my external turning. Just that fella there, tool number 1. So I'll just hit 1. And then when I hit enter, it goes across there, which is the offset. So I always use offset 1 as well, just so that I can go in there and change things if I really need to. And then we come down to the actual shape. Now Mazatrol is pretty simple like this in that you just tell it the shape you want. You don't tell it what to do, you just tell it what shape. So for the facing cut, the details you need. We've got our starting point in X. So for the facing cut, we're going to start out here and then run down like that. That's how an edge cut does it. So our starting point is our material OD, which is 31 for X. Our starting point in Z. So edge is different to all the other tool paths in that positive Z is out this way, and with all the others, positive Z's that way. So for Z, we just say 1 mil. our finish point in X and Z. So normally with a facing op, if you're facing a flat end, you'll just have 0 and 0. But if you're doing hollow bar or something like that, you might only want to face it down to, like, you know, 12 mil. You might have a 12 mil hole in the middle already. So just saves cutting a bit of air. And then you've got surface roughness. So this calculates basically what your finish cut's going to be, the feeds of your finish cut. So I'll just set that at 8, so I want this to look pretty. Okay, now next we're going to do a bar operation, and we want to do an out. So there's two different sorts of out and two different sorts of in, two different sorts of face. So the first out is when you're starting from the end and going out. The second one is if you're, say, starting back here and doing something. So it just changes the way that it rapids to where it's starting. So that's an out. Cutting point, again, that's just the largest bit where you're starting from. So I'm starting from 31 and 0, which will be, you know, that corner once it's faced off. Speeds and feeds, again, just hit auto. Set my roughing tool and finishing tool. Now you don't actually have to put a roughing and finishing tool. If you don't want to run a finish op on this, so say I wanted to do a few different bar out operations or whatever, and then I wanted to do a finish afterwards, I could do those all separate and then just do a finish one without putting a finish tool in all of those ones I just want to rough. But in this case it's a pretty basic part, I'm just doing that. So shape. So this is where you start off by telling it what you want. So with this part I'm going to be starting with a taper. Corner, you can put either, if you just type in a number, it'll be a chamfer. If you hit that R button, it'll be a radius. Starting point in X, so this is where you want your shape to actually start. So here we've got a quality not to scale drawing of the part that I'm making. So we're going to be coming in from this end. So my starting point will be 24.4. So all of this is done diametrically now. 24.4. And starting point in Z is 0, because that's our face there. So just leave that as 0. Now finish point is going to be up here, which is 29. So 29. Finish point in Z is 0.84. 0.84. Finish corner, we're not having any chamfer or anything on there, so we'll leave that. And surface, we'll put that at 8 because we want it to be pretty. And then I'm just going to run a line along, just along there, because I'll be grooving the rest of it out. So a line, no starting, keep it at 29, and I'll run it along to say 6. Keep that on 8 as well. Alright, so that's it for that out turning, so shape end. Then the next operation we're going to do is a groove operation. Two different types of groove as well. We've got out, out, same as what I said with the bar work. So this is in from the end, so it's a bar out, a groove out. And there's two different types of grooving styles. There's 0 and 1. So 0 is just a straight groove and 1's supposed to be a trapezoid groove. But I use 1 all the time for my straight grooves as well, because one of them measures from one side of the tool, whereas the other measures from the other side. So a 0 measures from that left-hand side of the tool. So if you're parting off a piece and you want to part it off to 10 mil, you've got to add on the length of your, the width of your grooving tool. So that I'd have to call that 13 mil. Whereas with this one, it measures from the other side. So I always use that one. Number of grooves. So if you're doing multiple grooves, this is where you put that in. I'm only doing 1. The pitch, seeing as I'm only doing 1, there is no pitch. Groove width, so I'm using a 3mm grooving tool, but what I want to do is I want to groove that 3mm, because I'm going to get down to this step here, but then I need to leave enough so that then I can run the tool in to actually part off. So that's about another 0.5 on there. So I'll groove this to 4.5, so that'll give me enough room to do that finishing one. Finish allowance, so this is if you're doing any sort of grooving where you've got to have more than one, shot at it, basically. So this one, because it's a 4.5mm groove that I'm doing a 3mm tool at, it'll shoot in and then come back and shoot in again. Then the finish allowance is what it'll take on a nice little extra cut. So I'll just put that at 0.1. And then your speeds and feeds, again, I'll just auto this. That's fine. The tool we're using is tool number 7. Little fella there. So 7. Offset 1 again. Okay, so starting corner. So with these trapezoid grooves, the starting corner refers to both of the top corners, and the finishing corner refers to both of the bottom corners. There's no way to set them independently, and I don't need anything on that. Starting point X will be 29, where we turned that down to, so 29. Starting point in Z will be 0.84, so that back face there, 0.84. Finish point in X will be 17, because we're just cutting down to there. Finish point in Z. Now this is still measuring off this side of the groove, so we still call this 0.84. Finish corner, we don't need anything in there because I want it to be a nice square end. Surface finish, we'll give that 8 again. And then we want to do, actually I'll throw this up in here, so here's another little bit to learn. So if you want to insert a section, so what I've done, I've done my bar out and then my groove. So I've done that bit and then done down to that step. I actually probably want to drill the hole first, so it's got a little bit more stability. So I'll just go up to the start of this groove operation. Then if I go menu button, insert, and then hit input, it'll whack another bit in there. And then, because I'm done with that bar out shape, but I want to make a new thing, I'll just go shape end, and there we are on a new line. So what I want to do there is drill, and there's different sorts of drilling operations. 0 is just a straight in and out at regular feed rate. Number 1 is in and then rapid all the way out. Number 2, I'm pretty sure, is in and then small rapid back, just a little peck. And number 3, I'm pretty sure, is just an all the way in smooth operation. I basically always use number 1. Drill diameter 10, so this is just my spot drill. Depth of first cut, so you can just auto this, but basically what it is, depth of first cut is how far the first peck will go in, and then depth 2 is the decremental depth, so first cut goes in 10mm, then it backs out and comes back in, and then it will go into 7mm, because that's your 10 minus 3, and then it'll come back out, and then it'll go into 4mm, because that's minus another 3, back out, and it'll keep doing that until it gets to this depth 3, which is your minimum depth of cut. So that's the minimum amount that it'll peck each time. I'll just leave that at what it is, because it's all going to be done in basically one cut anyway. Then you got surface speed and feeds, which again, it's all just auto, but you can change that if you need to. Tool number 2. No real need for an offset in this one. Go down and insert again because I need another line there. Starting point in Z is 0, finish point in Z is 1, because I'm just doing a spotting off. And then I'll insert another line. We want to do another drilling op. Number 1 again. 12 mil, so this is my actual drill that I'm putting through the hole. We'll just auto all of that. Happy with all that. And this is tool number 5. Insert another line. Starting point will be 0. Finish point. So we've got to get through at least 1.6 for that. Plus then I've got to add in the tip. So I'll just say 6, just for good measure. And then all that's left is to part it off. So we'll run another groove, out, trapezoid, 1 groove, no pitch, 3 mil wide, because we're just doing the width of the tool this time. Finish, we don't need a finish because we're just going to do it in one cut. And then just auto for speeds and feeds. Now we only need a roughing tool on this because we're not running a finish cut, because obviously once it's roughed it, the part's fallen off anyway, it's all done. So start corner, we don't need a start corner. Starting point in X will be 17, because that's my step. Starting point in Z will be 1.16, which is the edge of my part there. Finish point in X, so I've got a hole going through at 12 mil, so I'll just set that at 11, and then it'll just part it off, not bother cutting nothing in the middle there. And then finish point in Z, like I said, it's still measuring off the same side of the tool, so 1.16. No finish corner, set surface at 8. And there we are, that's the whole program, so I can hit end on that. In the end operation, it's pretty handy, not so much for just single things like this, but if you're doing multiples of stuff, it's handy. So you can get it to start the parts counter. You can get it returned to the 0 position or back to home or whatever. You can set it to go to another workpiece. So if I was doing something that required 2 operations for some reason, I can get it to just switch to the next operation. Continue, so you can do this if you want, like say you've got enough material hanging out to do like 10 of the same part, or if you're using a bar feeder of some sort. You can use continue, so it just keeps running the program for the amount of times you set in number there. So it can be set at whatever. And then you've got Z shift amount, which is how far you can change the Z offset each time. So obviously with something like this, we're parting off 1.16 plus the 3 mil of the tool, so 4.16. So you'd maybe shift your Z 5 mil. So then it shifts across with a little bit to face off still. In this case, I'm only making 2 of these, so I don't really care. So I'll just leave that. So that's all for making a program. If we then go into check, we can hit check continue and it'll show us where the tool paths are going to go. So there's our facing cut, a rough and a finish. Here's our external turning cut there. And then it'll drill. And then my groove. And the finishing cut. And then parting it off. So that's just a quick little check just to make sure all your tool paths are alright. That'll bring up errors if you've done something wrong, and you know, if anything's glaringly obvious, you'll see it there. In program file is where your Z offset is. So we'll just go down to work number 1, which is the program we just made, and from default Z offset's just 0. So we'll just quickly set a bit of a Z offset. So you just manually, the way I do it normally, just manually jog up to where it is. Seeing as I'm facing off a bit, I don't have to be super accurate here. So I'll just come up, yeah, that'll cut a little bit off there. And then I can just go Z offset teach, hit input, and that'll tell it where it's at. Chuck X, sorry. So this is the outside limit of your chuck there. This is for a chuck barrier, so hopefully you don't run tools into your chuck. Set that at 210 because my jaws aren't hanging outside my chuck. Chuck Z, so that's where your jaws finish. So if you want to actually teach that, you can run the tool up, you know, however close you're comfortable with. With this, I'm not going to be even going anywhere close. And then go C barrier teach. And then jaw data number. So you can have different chuck jaws drawn into it. So say you had some, you know, big elaborate chuck jaw that stuck out really far and you needed to machine up really close and your tools were going to be coming close to it, it'd probably be important to have that drawn up. Most of my soft jaws are pretty basic, and you know, if I'm going that close, I'm pretty careful about it anyway, so I don't bother actually drawing the truck jaw shapes. I just use number 1, which is already in there. Tail spindle length doesn't matter. I'm not using a tail stock in this, and actually I've never used that. So that's it for the program setup. So then we go into simulation now, and so you can see it's showing the chuck jaw there and showing my tool there. So it'll actually show you where the tool is at. So if I jog it across, it jogs across. Jog it up, it jogs up. So if we go, you always have to do workpiece figure first. So that shows our piece of material. We can hit shape, which will show us the shape of our cut. And then if we go menu, simulation ready, put into auto mode, simulation start, and this will show us what our tools are actually going to do. You can speed this up or down. So we've got a face cut, and then we've got a finishing cut on the face, and at 100% speed this will just show it at real time. So you can kind of see if you've got some speeds and feeds that are ridiculous. So a rough cut, finish cut. In comes, now that's obviously, I've set that wrong in the tool data. Thinks that's an internal tool. That's cool. So spot drill and then a finishing drill. My 12mm hole. And then here we come with our grooving tool. So roughing cuts and then finishing. So being a grooving tool, it runs the finishing cut from each side rather than in, across and out. And then we'll come in for our part off. And that is job done. You can actually zoom all this in a bit. Go start that again, workpiece figure. So you can zoom that in. If you hit scale down here, and then it'll bring up a cursor. Move the cursor to where you want to zoom from, and it shows you the scale you've got there is 30mm on that, you know, that distance is 30mm. So I could set that at say 60mm. Then when we bring up the workpiece figure, so see it's much smaller now. Or I could zoom in there and I could set that at 15. And now we're much closer on it, so we can actually see it a little bit better. So that's about all there is for setup. Now we can actually run the program. So we go out into the main screen again, so in position screen. Work number 1 that we're using. So we just make sure that's up there. Work number 1, happy days. Put in auto. We want coolant turned on, so the coolant will start when it calls for it. You can also put it into single step mode and optional stop mode and all that through here. I don't really need that. Pretty basic operation. I'm pretty confident it's going to be alright. And then of course the cycle start button. So here we are, it'll wrap it back to its tool change spot. Coming in, face off. Finishing cut. A bit hard to see through the window. Drilling. Grooving. And parting off. And we're done. And here is our lovely little part.